All right, in question 3, it says potassium sorbate is commonly added to diet soft drinks as a preservative. A stock solution of potassium sorbate of known concentration must be prepared. A student titrates 45 mils of the stock solution with 1.25 molar HCl using both an indicator and a pH meter. The value of the Ka for sorbic acid is 1.7 times 10 to the negative fifth. Write the net ionic equation for the reaction between potassium sorbate and hydrochloric acid. So remember, potassium sorbate, ignore the potassium, right? Because we're just concerned about the weak base here, which is the C6H7O2 minus. So that's going to react with hydrochloric acid, which is a strong acid. So it's going to be H plus and C6H7O2 minus, and that's going to produce your weak acid. So you got 1 point for that. In B, it said a total of 29.95 mils of 1.25 molar HCl is required to reach the equivalence point. Calculate the concentration of your potassium sorbate. So you need to take the volume of hydrochloric acid, convert that into liters, multiply by the molarity, that will give you your moles of HCl, right? Then it's a 1-to-1 ratio. So however many moles you get for HCl, that's the number of moles of potassium sorbate. And then you're going to take that and you are going to divide it by the volume that you use. And if you look at the very beginning of this problem, it tells you the student titrates 45 mils of the stock solution. So you're going to divide the moles by the 0.045 liters. Okay, and the answer you should get is 0.835. Now, I don't particularly love the way that they did this. If that works for you, fine. I don't love this setup, but you should still get the same answer. We've been doing it using stoichiometry, which I like a lot better. So you got 1 point for the moles of HCl, okay, and 1 point for the correct answer. Now, you don't actually have to write out the number of moles of HCl. You can just keep going, but they need to see that you tried to calculate the moles of HCl. In C, it says the pH at the equivalence point of the titration is measured to be 2.54. Which of the following indicators would be the best choice for determining the endpoint of the titration? Justify your answer. Okay, so if you notice, you need an indicator whose pKa is going to be close to where you have your equivalence point, right? So you have your equivalence point at 2.54. So I need an indicator whose pKa is going to be as close to 2.54 as possible. So that's going to be thymol blue. Okay, so you got 1 point for getting the correct answer. And since the question says justify your answer, you need to justify it. So the pKa for it is close to the pH at the equivalence point, okay? And that's your explanation, and you're good. D, calculate the pH at the half equivalence point. So at my half equivalence point, I know that my pH equals my pKa, which means I just need to take the negative log of my Ka, which is given to you in this problem as 1.7 times 10 to the negative fifth. So you get 4.77. So you got 1 point for that as well. Okay. In E, it says the initial pH and the equivalence point are plotted on the graph below. Accurately sketch the titration curve on the graph below. Mark the position of the half equivalence point on the curve with an X. Okay, so it starts off, you have your initial pH, you have your pH at your equivalence point, right? So this is just going to be the first half of the graph. Okay, and since you're starting off with base, but you're adding acid, right? Since you know the concentration of acid, but you don't know the concentration of weak base, it's going to be starting up high and then going down low. So that you just need to draw the first part of this curve. So it's going to look like this. Okay, and then mark halfway to your equivalence point, and that will be your half equivalence point. So notice your equivalence point is when you have 30 mils of hydrochloric acid, which means your half equivalence point is when you have 15 mils of hydrochloric acid. So you got 1 point for the half equivalence point, and your half equivalence point had to be consistent with your answer from D. You got 1 point for a curve that levels off to a relatively horizontal slope right at the half equivalence point, and then you got 1 point for a steep negative slope through the equivalence point, right? So you can see that, how there's that slope there, right at your equivalence point, how it's showing that it's going to continue going further down. All right. So F asks, the pH of the soft drink is 3.37 after the addition of potassium sorbate. Which of the species, your weak acid or your weak base, has a higher concentration? Well, at my half equivalence point, I know I have equal amounts of these two. And at my half equivalence point, I have a pH of 4.77. So since my pH is lower than that, that means I have more acid than I have base. So I have more HC6H7O2. And so you get 1 point for identifying the correct species and making a comparison involving the pH. So exactly how what I said, right? Comparing the pH at half equivalence point versus at 3.37.